5, 6 years of his life. Then he comes and meets you guys. And you show him this. What is that?
P.
Upside down E.
Upside down D.
Now what is it?
An upside down P.
And now what is it? you get it, right?
It's a little
Q, G.
All of a sudden, it's just like
9.
everything we've been like lived by, genetically programmed for thousands and thousands of years, out the window, out the window. And we have to come up with this, we have to adapt very quickly in order to survive to this whole new set of rules, where these are not the same thing anymore. They're very different, they're not interchangeable. I want dad and I want bed, or bad, or bid, you know, whatever. They're very different things. So, that's the third component that we find. And again, what is it? It's process. Nothing broken, nothing damaged, it's just process. So how they process information, if they're processing this the way they process this in the real world, they're going to be in trouble. Now, do 85% of the kids on the planet make this transition? Yes. But what about the ones like, Leonardo da Vinci, Albert Einstein, Thomas Edison, Walt Disney, and thousands of millions of others? For some reason, these guys, these intelligent, right? Because Einstein, he's not some guy sitting in a diner, right? Drinking coffee, right? These intelligent, creative people, for some reason, have trouble with this a lot of times. So that's what I was looking at. That's what I really became interested in. And what we found was that without breaking the child, you can teach them a different strategy. Can you turn them into a left-brainer? In my opinion, no. In my opinion, that's why in most therapies fail with these guys. That's why most kids are miserable, because everybody keeps trying to turn them into a left-brain learner. They keep trying to make them process these phonic sounds, these phonetic sounds, and process them sequentially and get them to see this like everyone else. It's, in my opinion, in my experience, it doesn't happen. If it does, it's a grueling battle. So what do? Well, like I did occasionally in school, I cheat. I cheat. I threw out the book. I decided that there had to be more than one way to read. And when I say I definitely had some help on this. Okay? I threw out the book and decided that if this doesn't work, let's forget about it. If this doesn't work, let's forget about it. And if this doesn't work, let's forget about it. Well, how do you read? Okay? Well, let's take the sound, the auditory part. If we were teaching deaf people to read, would we teach them with phonics? No. And I say that, but most of the kids that come to me, they already have the phonics down, actually. They just don't have it down enough. And if the child was blind, would we teach them this? No. So there's got to be different ways of learning to read. So what I do is I take the process of reading and I change it so that it fits this group here. And one of the things we do, and probably in its very, very simplest form, is our spelling strategy. And I think somebody has already seen that in action, right? Has anybody seen that, our spelling strategy in action?
I don't know.
No? Oh, okay. A little bit.
A
little bit, yeah. So what we do is we move the information from the left brain to the right brain. Now, if the left brain sees in words, the right brain sees in pictures, which one do you think sees in color? Pictures. And the left brain is processing pieces in order, sequentially, in parts and features, right? Which one do you think likes to look at the whole picture all at once? The right brain, yes. So how do we accommodate that? Well, we take our spelling words and we put them, first of all, in color, right? So it takes that information. You can't store color in the left brain. So we have to move it over to the right brain. And then it becomes not separate things that we have to remember in order and sequence. It just becomes a picture. Like a picture of your car, your dog, your house. And the funny thing is, and this is part of the way we teach kids to spell, once you learn it like this, you can actually spell forwards and backwards. It doesn't matter. In fact, the really visual kids, you'll see them actually spell easier when they go backwards because they're not tempted to use the left brain anymore. Okay, is that cool? So that's a little bit about starting to get into the strategies. But now I'm going to go back to 21, page 21. And I thought you guys might appreciate this. And again, I'm no Waldorf I'm not even a teacher, much less a Waldorf teacher. So I'm not an expert on the learning styles or the temperaments. Sorry. But I thought this would be interesting. And I graphed it out. It was very interesting to me that as I looked at the temperaments in terms of process, so we have kind of really 4 kind of basic, important functions, kind of ways of processing information. There's visual versus auditory, and then there's also kinesthetic versus what you might call logical or rational, right? And those are kind of the opposing forces, if you will. So what I did was I took the 4 temperaments, along with the characters from Winnie the Pooh, and put them on this, and showed them on this graph. So what you can see is that, and I think this has officially been debunked in most literature, in most circles, this idea that you can teach a child visually, or you can teach a child auditorily, and they'll like somehow learn better that way. Forget that. It's much more complex. It's about processing things sequentially rather than holistically. It's about hearing the features versus the why, the looking at the kind of like the why. So the how, here's the how, here's the why. Now, unfortunately for this little minority here, let's take a math book. How is every single math book laid out? It's a series of steps. So if you don't have a good sense of time and order and sequence, there's a good chance you're going to struggle with math. And I noticed something very funny. I noticed that no matter how much these guys struggled with math, they never had a question about how. They would sit and watch the teacher explain it. Because you guys are like, well, why don't they raise their hand? Okay? They'll sit there and they'll listen to the teacher explain it, and they'll never have a question. Why? Because the how makes sense to them. They understand how you're going, how you're doing those steps. But what they're not getting, that this group tends to get, they don't get the why. By looking at the how, they don't get the why. So what they do when they go home, because you give them problems 1 through 20, right? 1 through 24. They go home, and and the first thing they do is they do the 3 problems that you gave them, and they do those pretty easily. Why? Because the problems you gave them are exactly like the ones you just did on the board. So they can imitate what you did, and they don't have any problem. They go home, they take their homework home, and they go through and they buzz through the first 7. Because again, the first 7 are exactly like the ones you did on the board. But problem 8 is now different. And they can't solve it by just imitating what you did, so they have to like think. And now they have to go way outside in this box that they live in with all these possibilities and try to figure out, okay, why did she do that? I know what she did. Why did she do it? And they'll eventually figure it out. And a couple minutes later, about 4 or 5 minutes later, they'll go on to the next one. And maybe they'll get 3 or 4 in a row. But pretty much by the time they get down to, number 17 or 20, there's so many things out of order and sequence with what you showed them, they're lost. Totally and completely. So the question for these guys is, and you can tell this to all their parents. This is how I teach parents to tutor their kids and work with their kids. The question that they have to answer is, why? These guys, all you've got to do is show them how, and they're fine. They're good to go. Boop, boop, boop. They'll go. They might struggle with some of the real complicated stuff, but they're pretty much going to be good to go. These guys, if they don't understand why you did each of those steps, they're lost. And that's when math homework becomes an hour and 45 minutes. And usually a fight. And again, like I said, it's really hard in the classroom because they'll never have a question. They're never going to ask you. You're never going to hear these guys say, "Well, what do you mean by that?" Or "How did you do?" No, because they're intelligent. So it's everything you do. The how is always going to make sense to them. Anyway, so again, like with parents, what I tell them is, you sit down with your child, don't do the homework for them, but go back to that first example in the book. Every math book has the same thing, right? You open up your math chapter, and you've got vocabulary, you've got, maybe it says, here are the skills that you're going to learn, and then it has examples. And if you go through those examples, and you ask your child, why did she do this step? Why do you do this step and then this step? And once they can answer why, then, well, I call it the Oompa Loompa effect. In the new Willy Wonka, all the Oompa Loompas are computer generated and they all look exactly alike. They're like dominoes. And once I get why, I know I can skip all of these, I can jump to the hardest problem on the page, and they'll do it like that. It's really amazing. Nothing changed. Nothing changed in the child except he answered the questions why, and then he was able to do it. So I don't know. Is that of any use? That whole.
I have images of particular students that some of these apply directly to.
Awesome.
That's how.
Awesome.
Yeah.
On page 22, there's a little bit more about those learning styles, and you can see the qualities. It's not just showing them a picture versus using words. It's how the information is organized and presented. Unfortunately for you, while you're following the layout in your history book or your science book, and you're explaining all those features and all those qualities and all those important step-by-step events, and 80% of your class is they're right along with you, this other group is saying, please God, will she get to the point? Why is she telling me this? Why am I sitting here? Whoa, what's he doing out there? So their big picture, it drives them crazy when they don't know why. When they don't know why they're sitting there. Again, I don't even know how to begin to help you guys with that respect.
So that's the kid who says, I don't get it, when you're like 2 minutes into what you're bringing.
Yes, he's a why guy.
I don't get it.
Why? I don't get it. Why are you telling me this? Why do I need to know this? Very cool. You can see the left brain guys, very, very good with features. They understand the features, whether it's science, history, math. The other side, they're looking for patterns. They want to show me the big picture and let me see the patterns. So after I was doing cost estimating for about 3 years, I could see patterns in the bid climate. And I started adjusting my numbers accordingly. Nothing in the book said to do it, but I was fudging my numbers. Of course, it would come back that, you know, okay, why are your numbers different than the book? Because, you know, I did a lot of schools, and when you tell a school district that their next elementary school is going to be 11.2 million and not 9.7 million, they want to know why. So it actually took me about 3 years to work out the numbers. And I came up with these weird algorithms for, you know, the distribution of resources of contractors and materials, and this probable distribution with probability of distribution, and then this curve which kind of outlined the anomalous bid results, and then you could pick this range right here and you say, oh, well, that's what the price is going to be. Anyway, but again, pattern recognition, not features, not that whole thing. Experiences the world auditorily. So these guys, they live in their that verbal conversation in their head. Very comfortable in your class. Very comfortable. They're kind of like in sync. As long as you keep the conversation moving, you know, and they haven't watched too much TV, they're good to go. But the visual learners, these guys, they're literally processing information about 400 times faster than you can talk. There's almost no way, I mean, short of doing a jig, you know, something, setting your hair on fire, there's almost no way to repeatedly and what's the word I'm looking for? Continually hold their attention. They're just, I mean, they're just in a world they're moving at the speed of light. And I mean, look at this classroom. How often does this classroom change visually? I mean, really change, right? By the third day, you know, you know what it is. I mean, I walk into a doctor's office, like Avery, you know, I sat in the doctor's waiting room for 15 minutes. I can tell you every magazine pretty much that's in his magazine rack. I can tell you the picture on the wall, what that looks like. I can tell you, I can draw how many chairs and tables and everything. I can tell you what's on the nurse's desk. I just, you know, I was casually there for 15 minutes. Anyway, any use, value? Again, I don't have any magic bullet. I don't have any magic answer.
I just have a question.
Yeah.
I mean, I hear what you're saying and where you're going, and I get that because I see it with children.
Mm-hmm.
And at the same time, I see those kids that have the ADHD and the kids who have these really, you know, processing issues where they're, you know, having a hard time attending or staying still in their seat or whatever.
Mm-hmm.
But I've also at the same time seen those kids be absolutely mesmerized and compelled by a teacher's storytelling.
Yes.
So they are processing over on this stuff.
Yes.
And
No.
it is answering to something.
Yes and no.
Something's happening there where they
Yes
are
and no.
able to calm down
Yep.
and they are able to attend
Absolutely.
for that period of time.
And that's why it's there's no child that exhibits the symptoms of ADHD all the time, round the clock. If you did, you'd be skinny and dead. Okay? I mean, because you have to switch over. You have to switch over from your, at some point during the day, you have to switch over from your sympathetic, maybe that's on the next page. Yes, the autonomic nervous system. At some point, you have to switch over from your sympathetic fight or flight, go, 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 boom, 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 thinking outside the box, puzzle-solving brain, and physiology to sleep, rest, digesting your food, growth, healing. All that stuff happens when you're in the parasympathetic mode. And we all have to switch. We all have to switch over sooner or later. Now, for some kids, it may be go, 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 go. Go, 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 go.
I'm that kid.
Yeah, with the buckyball.
Very good.
I had a quick question, and it's kind of funny that we're having this meeting because I just had an email from my daughter's mom. We've been emailing back and forth. She's in the first grade, and teacher emailed her wanting to set up a conference. She's getting a D in spelling right now. She's always had a lot of transposal issues with, transposing letters.
And I'm sorry, how old is she?
She's 6.
She's 6, okay.
And-
And as you know, up until about 6 or 7, transposing those is very normal.
That is exactly.
So if that was the only thing, it would not draw my attention. But if I saw transposing letters with, some other things, not being able to follow instructions, 2 or 3 instructions.
That's my daughter.
Not, kind of, this is the group, in one ear and out the other. This is the group that was invented for.
Yes, and yes. Well,
Go ahead.
My question is, at what age is it more appropriate to? Because I'm talking with right now about where should we go, who should we talk to, and is this a dyslexia? Is it ADD? Is it dysgraphia? What is it, and how do we assess and diagnose? And all of a sudden, this whole world of issues have just gotten cracked open, and now I'm here, which is great.
Awesome.
And so I don't know, I don't know really what I'm asking, other than what is an appropriate age in your opinion to start dealing with stuff like that?
It's actually never too early.
Okay.
Most kids, you can spot them when they're 2 years old. You can spot them. They're on a different level than most kids. As long as you had more than one child, you have 2 kids, you put them side by side, you can tell one of them, they're more active, they're more curious, they're driven. There's something about them. They can't let stuff go. They just they sink their teeth into something. They gotta go on to it. They may struggle with transitions or changes in schedule. They may be a little oversensitive, either physically, right, like to clothes, or just sensitive to the emotionally. Just the little things will trigger them. They may know things like I knew a girl that was 6 years old or maybe 5. She could spot a neighbor's car in the shopping mall by recognizing the license plate. But she couldn't spell the word "the." Little gap there, maybe? Something's not quite right. How can she do that but not that? It clearly was not a matter of intelligence.
That's what I've noticed is there's this kind of overcompensation where most people in that middle part of the spectrum, they have an even amount of marbles sort of distributed to the different skill jars. So
Yes.
whereas my daughter, she lives in her imagination. I got her a dollhouse for Christmas.
So
and she can sit in front of it for hours.
Yes.
But when it comes to reading and writing and spelling, and it's just no patience, and a lot of things that are transposed and fractured words, and it's kind of that's
Yes.
what it is.
It hurts, Ryan.
Yes.
We're like, why isn't she in my kindergarten?
Oh man, yeah.
See where you are.
I know.
Why are you pushing her?
I know.
Got it. So on one hand, it's probably too early to do a diagnosis,
Sure.
but to get a feel for her learning style, to see that maybe she's more up here than over here, you can easily start doing things. So I'll mention I put a bunch of I'm always putting videos and stuff up on YouTube, and there's one called Easy Math. Okay, so I take this girl. This was during our teacher our learning specialist training. A couple of little kids came in. One of them was the daughter. She'd never done math before. No math at all. So the girl that you see in that video had never ever done math before. She knew kind of how to count up to maybe 20 or so. And I took her, and using just blocks, nothing fancy, no sophisticated computer programs or any weird science. I just took blocks, and using something that she could feel and touch in the real world and relate to, boom, we did addition, subtraction, multiplication, and division in 20 minutes.
Can you demonstrate how you did that?
Mm-hmm. Yeah.
You need a guinea pig? Someone come up and a demonstrator?
Oh, and these are things for people to take later on, if they want. We have our parent support group. This is the booklet I did, Gifted Not Broken. And And for older kids, we even have this higher grades in 10 days program. They come in every day for 10 days after school. We show them how to do their homework, how to study, how to walk through every subject, and boom, their grades will go higher in 10 days.
And what
So,
age do you do that to?
that's usually for about 12 and up.
12 to what? 18, or does it go past there to college?
All the way. Last year, my oldest student was 63.
Wow.
You're talking about grade school?
Not too late for me.
Oh, sorry. I didn't. That's good. I meant age 12. Age 12
Okay.
and on up. Age 12 years old and on up. So all I did was I started her out, and I said 1, 2, 3. Now notice that I use this little shape here. Same thing, just like you see on dice, right? Or deck of cards or whatever. And then, so 5, and then I say, well, 5 take away 1, or 5 take away 1, 4, and 4 plus 1. So I'm using the language, and she's seeing it in the real world. And 5 minus 2, 3 plus 2, 5 minus 4, 1 plus 3, or 2, whatever. And I just boom, 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 and in like 5 minutes, she got addition. Another 5 minutes, she got subtraction. And then I said, okay, what if I have a group, but my group only has 1 block in it? If I have one group with 1 block, how many blocks do I have? 1. What if I have 2 groups, and each group has 1 block? What if I have 3 groups? Blah, blah, blah. So then, in a pretty short period of time, so what if I have 2 blocks in each of my groups, and I have 2 groups? So I have 2 blocks times 2 groups. 4. 2 times 2 is 4. So now, is she going to memorize her times tables from this? No. But did she get, after about 20 minutes, so here's, 3, and so if I have 3 groups of 3, how many blocks do I have? 9. And if I take my 9 blocks and I divide them up into 3 groups, how many do I have? 3. So she, in 20 minutes, 6 years old, she got the concepts of addition, subtraction, multiplication, and division.
And I know memory is out the window, but how about the retention of the concept? Did she retain conceptually?
Yes. Now, from one day, no. No,
How
she's
long?
not going to retain that concept from just from doing that one experience. But with a little practice, yes. But I'm talking about days, not months or years to get the concept.
So how often would you do something like that with someone like that to cement it? And
It would probably take a couple of days to cement it in. And after that, we move on to the actual memorization, which would be, again, utilizing the concept. But I don't do the memorization. See, I see a lot of kids that can rote memorize times tables and counting by tens. And here's what I see. I just had a little guy. He finally had his breakthrough. We've been working on this for a while. So we would go, this is what would happen to him. Because he learned to count 10, 20, 30, 40, 50, right? So he would 2, 4, 6, 8, 10. And then this is how he would count. For months, it was really interesting. It wouldn't click. And I'm being honest, it really, there was a couple of things happening, but this is how he would count. All right, Jason, how many blocks do we have? 10, 20, 30, 40. All right, let's do something else. How about that? How about this? Okay, count the block. Okay, 5, 10, 15, 20, 25, 30. See, he had the rote memorization down, but no understanding. He didn't understand that this is 5 blocks, and this is 1 block and 1 block, and that they're different things. There was no connection in his brain. And for some reason, it took a while, but then, in fact, his mom was telling me just a week ago that it like just clicked, and it was just like boom, 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 and then they were doing like 3-number addition, and he buzzed through this test like it was nothing, and the teachers were like, "Whoa, where did that come from?"
So could you